So I got a great question this week about creating splines from external spreadsheet data and how we can do that, how we can do that associatively. This is one where we don't have an out-of-the-box command in NX to do this, but I was thinking about it and thought about how to do this with an algorithmic feature. And it actually turns out to be pretty easy with an algorithmic feature. So I'm going to run through how to build that, and we'll take a look at that here today. I'm going to grab, just getting something arranged here. There we go. Let's do this. I've got an existing one here that I created already that, and I'll show you how this works. So right now, as we double click this guy, it just asks for a CSV file and comma separated values spreadsheet file. And we can choose one, and I've got 4 of them out here that have some different airfoils on them. I've got this doing 2D airfoils right now, but as you see when we put it together, it's really set up for a general 3D shape. So this is a different airfoil you see that's got a little bit of a hook on the tail, a little bit of a pointier nose out there. And again, we can grab that and go and select a real simple NACA 4-digit airfoil here, and you can see that updates quite nicely. So let's go build it. Okay, so I'm going to hide this one right here, and let's go build a new one. So I'm going to come into Algorithmic Feature up here, and this is going to take us into our logic editor environment. I'm going to scoot that down there. I'm going to get a little more real estate for this, and we'll see our airfoil develop down here below. The way I like to work, we do have a fairly extensive node library that's in here. I personally like to work using the search a bit more than browsing individually, but that's also partially because I know what I'm after. So we can look at this, and you can see if you like this way of working. As you can see, I've started off there, typing in CSV. If we have nothing in there, we don't see anything. I know I'm going after a CSV file here, so I can grab this, and I'll double click that to bring that out into the canvas here. And this, as you can see, kind of like NX selection, same concept. We've got a little red star there next to this that tells us we're looking for a file. So I'm going to go and grab a file, and there again, let's grab that same airfoil. And as we do that, that should turn green. Yep, there we go. And this node here also is telling us that we've got green, and it's found the file, and it's ready to roll. Okay. Now, what we've got inside there, of course, is a table of data, right? And so I'm going to put in table, and there's a read table here that's going to read a table from a file. And it, as you might expect, takes a file as an input, which we happen to have here. So I'm going to grab that and hook that up, and that should now tell us that we've got a file. So this particular one's got 35 rows and 3 values. In fact, let me Alt-Tab over here to that file. That's this one. And it looks like this. I formatted these like this. I've got a header row in there with some titles. And at the moment, those can really kind of be anything. And then, again, this particular airfoil data that I've got really is 2-dimensional. So I've got really X, Y's in here, and I've inserted a bunch of zeros here in the Z. This particular one is, again, about 35 coordinates long, and others are longer, right? And that was kind of one of the requirements. Then talking with this customer this week, was that we wanted to be able to have a dynamic set of coordinates there, and this will do that, and you'll see how that works here in just a second. So we've got these 35 rows here on this particular one, and as we bring in these 35 rows, we're going to get that as table data, right? And so as we look at this particular data here, we'll see that it looks like a table, right? Now, I want to get that from being a table into a bit more usable information. And so what I'm going to do from here is I'm going to deconstruct this table, and that's going to start to break it down a bit. So we can actually do that straight from here many times in the logic editor here. We can MB3 on an output node, and it'll suggest a thing to do next. That list viewer is the thing we were just looking at. Deconstruct here is one that's going to, again, break it down a node. This will connect it for us automatically. The deconstruct node is actually a really interesting one. You'll notice here that as you bring in a deconstruct node, it only has the left-hand side because it doesn't know what you've plugged up to it yet, right? But this will essentially take whatever object you plug into it and kind of break it down to the next level, right? So if you start with a body, for instance, it'll start to break it down into faces. You stick a face in there, it'll start to break it down into edges and so forth. In this case here, it's going to take that table and start to break it down into a title if there is one, and a header row if there is one. And this one, it does show a header row there. If we look at that, we can see it's got that XYZ coordinates that are those ones. If we tab over, these guys up here in the header row, right? And then the rows below. So it's got that 35 rows of data below. And here again, these are still showing up as rows with kind of a triple in them out there. And to get our points, what we're gonna do is we've got a point XYZ here that needs really separate X, Y, and Z coordinates coming in, right? And so because of that, we're going to take this row and split it up a bit more and break that into X, Y's, and Z's, and then pipe those into this point. Okay, so I'm gonna keep that point and scoot that over a little more. That's kind of our destination, right? That's where we're headed. I'm going to take these rows and decompose these one more, deconstruct these one more, okay? And then we'll see what we end up with here. At this level, as we come out, let's look at our data. Here we've got kind of a list of lists now, which is nice, okay? So for each one of these, we've got a 0, 1, 2 that are the each item here. We've got a 0 and then a 1 and then a 2 and then a 3. And in each one of those, we've got a sublist that are the individual values now for those coordinates, which is really what we're after. So that's really good. So from there, what I want to do now is start to go and select some of those individual list items out there. Okay. So I don't have the list item right here. But I'm going to go grab it over here. I'm going to try item and see if, yeah, that gets me quite close. So let's grab list item. And what this is going to do now is let me pipe in this list right here. And then I can create an input for the index here. And it by default is going to be 0. And what this is going to do now is go to each item in the list and pull out the index 0 for that item in the list. And so the net result of this as I come out the other end is that I'm going to get now this essentially first column, the X coordinate column. So this starts with 1, and you see the 0.95, 0.9, 0.8, 0.7, 0.6, right? That's going on there as it steps back along the airfoil. And that's this guy here, the 9.5. That doesn't look right, does it? Oh, actually... Oh, it does. 9590 and then 8765, right? So there's our 9590 and then 8765. Yeah, so that's our first coordinate, our first column data, X data that's coming out there. That's good. Okay. Now I want to make X, Y, and Z here. So what I'm going to do is grab this, bring this over a little bit. So I've got some clearance here, and I can grab both of those and copy and paste both of those together. Actually, this one just for fun I'll have come straight over. And let's do that again. Copy and paste that one more time. And as I do that, I can bring in a Z. So let's do that and grab those. And I'll bring that down just to make it look cool. And we'll grab 1 and 2 now for these. So this one's going to grab that first item out of this list over here, right? The sublist. This is going to grab the index 1 and the index 2. So essentially, this is going to grab our X's, this is going to grab our Y's, and the third one's going to grab our Z's. Okay. So these should all be 0, for instance, right? These are the index 2's that are coming off there. If we look at this, sure enough, these are all 0's, right? So again, this is our index 0, index 1, index 2 here. These are all of our 2's. Our 1's should be this 99, 18, 32, 45 coming in here, right? And again, that's these guys in the middle here. So we'll check that. And yeah, that's our 18, 32, 45, right? Coming in there. So here's our X, Y, and Z now, right? So these now we should be able to pipe into X, Y, and Z right here. and that should give us our points. Okay, and we can preview those down here, and they're very, very small. So let's fit that. Can we fit that? Nope, we can't fit it, but I can roll up on it there. So there's our 35 points down there, okay, that we can see. From here, of course, we want to connect these with a spline, right? And so what we'll do next is grab a spline. And there we go. So this is going to be a spline through points here. We'll bring that over, line that up with our points, send in the points. There we go. And this, of course, will preview. Okay. Now this has some other inputs down here. These are not required inputs. It's going to default here to things, but I want to create these so we know what we're doing. I don't know what a 0-degree spline is here, honestly, but I want this to be a 2nd-degree spline. I want this to be degree 2. That's going to be a bunch of 2-degree segments, and it's going to help prevent reversals as we go around there. It'll just be a nice clean look. The closed here is an option that lets us do either an open spline or a closed spline. This is useful if we're trying to do a closed loop spline here, for instance, that we want to be kind of continuous all the way around, right? In this particular case, we've got a point on the back, the trailing edge of the airfoil, and as a result of that, I want a sharp corner here. I don't want... And I've got 2 coincident points also in the airfoil definition back here, and so I don't want to have a continuous rounded corner on the trailing edge back here, right? It is going to be closed in the end just by nature of the fact that the 2 endpoints are coincident there, but it's not going to be a closed spline, so to speak, if that makes sense. So anyway, this will have a start point and an end point. They'll happen to be coincident at the back here, but we're not trying to achieve continuity across that closed end, if that makes sense. So I want to choose false for that one. And the type here, yeah, we are doing through point on this as opposed to, what's our other option? Do we have another option? Yeah, by polls. We are using points here instead of poll definition. Okay. So I'm going to go ahead and leave those in there. We'll see these in the UI definition in a minute. We can turn all these off actually, which you'll see how to do that in just a second. So there's our spline, right? And with our spline, we can send that to output now, right? And we can either again do that from the MB3, or we can come up here and choose an output node. Either one of those will work to get us there. But that's really our rule, right? That's the whole rule. So again, coming over from the left, you flow left to right, we're going to choose our CSV file. We can read that file. It's going to create a table, read a table of data, right? And then we'll deconstruct that table a couple times to get to rows and then to individual cells. And once we've got to that list of cells that comes up here, right? You can look at that one more time. Again, we've got really a list of lists here, right? Where each row is showing up here now as a sublist of 3. And then from there, we're going and viewing list item and saying, okay, for this list item, I want to grab object that's the index 0, this index 0 right here. And that's going to grab that value and then this value here with index 0 and down the list and do that dynamically. We'll take those, pipe them into our points here to create our 3D points, and then send our points into the spline and so forth, okay, to create the curve. So that works really well, right? And then we can go and grab a different CSV file here if we want, and get a different result. Okay, so we can go grab, say, this airfoil instead, and as we do that, that's going to go and update. And this one's got a different scale of the points here, but that's obviously a different one. And if we look at our table here, also this one's got 79 points instead of probably 78 rows of data. Yeah, or 79 rows of data. Yeah. In this particular one, yeah, instead of 36, right? So this is a really nice dynamic way to read that file, collect up the information, and then it's going to store it as a feature, right? Which is pretty cool. So what we can do here now, if we look at the input for this, the dialog that this is starting to try to create for this new rule has everything on there, right? So we've got all our spline options, and these are our indices, remember, for our X, Y, and Z, our 0, 1, and 2. There are these inputs right here. We don't need all of this on our dialog, right, as the end user interacts with it. So what we can do down here, for instance, is come, and the titles here on these are also the titles that are showing up in the dialog here as well. So for instance, we might come in here and say, let's rename this one to our, say our input data file, right? Call that, and then this string in here, we'll maybe simplify this and say select CSV file. And these indices we don't need on the dialog, so I'm going to hide all three of these guys here, like that. Similarly, our spline parameters, I always want this one to be degree 2. This particular one, I'm kind of headed for airfoils, right? I'm going to leave that false and leave that as through points. And so what this gets us to is a much simpler dialog here, right? That's going to have really just the CSV file as the input. We can name the rule here if we want to at the bottom. Let's see, the title of this object up here, we can come to the properties and set that. So we can call this right here, say, spline from CSV, for instance, and we can put in a description there, right, that this creates a spline through, there we go, points from a CSV file, and we might put in more information about exactly how that's formatted and so forth. But at any rate, that's gonna give us some title on here and so forth, right? A little more information as we go to save this into the file. If we finish right here, what this will do is save this directly back into our part file, which is totally fine. If we're doing that in the context of a specific part, we can do that and save that there. If we want to save this or save as, here we can go and save this off into the reuse library if we want to as a rule as well, right? And I, of course, have done that because this is pretty useful. But yeah, you can save this off, and that'll create one that you'll see in the reuse library. We'll see that in a second. So let's go ahead and finish this. This will go back again and create the feature inside this model. And so that's this second algorithmic feature right here is the new one that we just created. This other one's the previous one, right? But here again, we can double click this to edit it, come in and choose a different airfoil, right? Choose this guy, for instance. We'll say OK. That'll create that. We fit the screen. Again, the scale of the points is a little different there. I think this one and this one are, yeah, these two are the same source for the airfoil data, so they're a similar scale. But anyway, that's how that works, right? It's kind of cool. Again, double clicking here will get us the simple interaction for this guy, and if we MB3 and choose edit definition, this will take us back into this data here, for instance. To go and interact with it. Okay. One just quick one here that may be of interest, right? Here we know we've got z coordinates that are all 0. If we know that our input data file, for instance, only has xy data, right? We might have just xy data up here. We might come in here, say if I take off the z, so this is not coming from the cell data anymore, right? I might have, for instance, here, if I had a number list here for our data list, let's do that, coming in, right? The nature of this is I could put a 0 in here, for instance, like this. So I've got a short list here for my data, have that come in as z, right? And I don't need to create a big long list of these. What it'll do, the nature of algorithmic modeling is it'll take this list and then actually repeat that list again and again here as it has more data coming in for x and y, right? So this will still create all of the points out here that are all 3D. It's all creating the airfoil out here still, but just feeding in a constant 0 here, for instance, for z. That's a possibility as well, right? Depending on the format of your input data. I chose to do it as a general purpose XYZ, all three of them in there. I'm manipulating the data file a little bit to add that z coordinate to make it a little more general solution. But usually the airfoils, or airfoils specifically, are going to be planar, right? But anyway, that's just a concept that's in there, right? If you have a number in there, you've got the long list here, short list here. repeat that repeat that as we go to build the points. Okay. So yeah, that's a look at how to do that, and I hope you find that useful.